3-eye atlas is observed all night, and the next night it looks as if its surface has been replaced. Not slightly different. Not a new crack has appeared. Specifically, a different material, a different reaction to light, a different skin. And the most disturbing thing here isn't even the fact itself. The most disturbing thing is the speed. One night, between two observation windows, while the Earth was simply spinning on its axis, the object managed to do what nature usually takes weeks to accomplish. From the outside, it looks boring. A sharp change in optical properties. It sounds like a line in a report being skimmed, but to put it simply, it's like seeing a new color and texture in the stone, as if yesterday it was granite and today it's polished metal. And this is where the real story begins. Because such things don't just appear out of thin air. Behind these optical properties, there's always something physical. Particle size, a layer of dust, ice on the surface, a fresh ejecta, a crust that's baked and changed. In a normal comet, all this changes gradually. The sun heats it, the ice evaporates, and dust rises. The brightness profile drifts like a thermometer. Even if there's a burst of activity, it looks like a messy explosion, not a neat resurfacing. But 3-eye atlas behaves as if it knows precisely how to do things carefully, as if it has modes, as if the surface isn't just something that happens, but something that can be turned on and off. You might say, maybe it's just an observational error, and that's the first thought for any normal person. The Earth's atmosphere, calibration, sensor noise. Sometimes a telescope sees one thing and then another the next day, because the conditions are different. That's why this episode only becomes a sensation when three things coincide. First, it's seen with more than one instrument. Second, it's repeated across different ranges. Third, it fits the overall dynamic of the subject, not just a random shot. Imagine a table with an object lying on it and you shine a flashlight on it. If the surface is rough, the light is scattered. If the surface is smooth, the light is reflected differently. If there's dust, it'll be one thing. If there's fresh ice, it'll be another. Optics are the language of the surface. They don't lie. They can be noisy, but if the noise disappears and the signature remains, then the surface has truly changed. And with 3-eye atlas, that signature has become too clear, too confident. In reports, this kind of thing is usually described dryly. Change in spectral slope, increase in reflectivity, polarization shift. But the viewer doesn't need to know these words. The viewer needs to understand the meaning. The object reflected light the next day, as if it had different skin. Now let's get to the most important part. What could have replaced the outer layer overnight? There are several natural mechanisms, but each one leaves a trace that should be visible. The first option is a dust emission. The comet spat out dust, the dust settled on top, and the surface became darker and drier in appearance. But then you see the comet in a cloud. You see it expanding. You see a tail that changes shape. The second option is the release of fresh ice. A thin layer of frozen particles can make an object lighter. This appears as a whitening. But again, this must be accompanied by gas, a growing coma, something escaping. The third option is a crust. The surface could have baked. The outer layer heated up and became denser, like glass on sand after lightning. But for the glass to form overnight, you need a sharp heat wave and a rapid release of gases. And here's where the odd thing comes in. Where's the source? If the object is far away, the sun is dimmer. If it's close, yes, activity increases. But then you have a clear reason. Heat. But here, the shift doesn't look like an increase in activity, but like a shift in material. The most disturbing explanation sounds simple. A layer was torn off. Not by being thrown out, but as if it were peeled off. The thin, dusty skin that had accumulated suddenly disappeared, and we saw what was underneath. Do you understand why this is shocking? Because the underneath of a comet isn't smooth rock. It's usually loose ice mixed with dirt, porous and fractured. It shouldn't appear as pure new material. But that's exactly what it looked like, as if the top layer had disappeared, and in its place appeared another, smoother, more collected. And all this happened not in a season, but overnight. You can think of it like changing clothes. Yesterday, a matte jacket. Today, a glossy one. And if that's true, then the question is, who or what can change clothes for an interstellar object so quickly? I don't say aliens. That word kills a story because it's too simple. It's like a close tab button. Real fear is always quieter. It's in the details that don't add up. Let's look at what technology records. Telescopes see light. Radio antennas see molecules. Navigation sees trajectory. And when the surface changes, something else often changes too. The acceleration from the ejecta, the shape of the coma, the behavior of the tail. And if on the same night when the skin changed, a slight trajectory distortion appears in the calculations, then it's no longer a matter of how it looks. It's a matter of what it does, because the surface and the dynamics are connected. Imagine pulling a sled through snow. If the runners become smooth, the resistance is different. If the surface becomes sticky, it's different. If the 3-eye atlas's roughness changes, it may lose gas differently and experience microshocks differently. So changing skin isn't just cosmetics, it's about controlling how an object interacts with space, and if it can change that overnight, it can also change how it flies. At such moments, the phrase, additional observations are needed, is usually heard, and yes they are, but many don't understand what this means in practice. It means we're running out of time, because the object has a tempo and we have a schedule. Earth-based telescopes depend on weather and nighttime. Space telescopes depend on the cue. You can't just snap your fingers and keep it under surveillance 24/7, and if it switches overnight, it will do so during the windows when we're not looking. That's why it feels like a game of hide and seek. Not because he's intelligent, but because his behavior doesn't align with our observational rhythm. He lives on a different timeline, and it always feels like control. And now the most dangerous question. If this isn't a coincidence, if this is truly a change in the outer layer, then how many times has it done this before, while we dismissed it as a regular dirty comet? How many times did he change his skin mid-appearance, looking like a dusty rock or an icy ball or something else entirely? How many times did he tailor his mask to our models so we'd close our eyes and say, yeah, that's how it happens? You know what makes this story truly creepy? It's not the cryptic words, it's the simple idea. If an object can quickly change its outer layer, it can also quickly change how instruments see it. And so, observations become more than just observations. They become negotiations. We look, it shows. We turn away, it changes. And this is precisely the moment when space ceases to be a backdrop and becomes a participant. If it were simply solar heating, the picture would be boring. The closer to the sun, the more activity. The further away, the quieter. A smooth curve, no surprises. But the change in the outer layer overnight doesn't resemble a smooth curve. It's like an event, a node, a point on the road where something happens, and afterward the surface is different. It's like you're driving down the road, and just at one point the car's engine sound suddenly changes. And the most important thing is that it can be verified. Not by emotion, but by geometry. Where he was at that moment, what was nearby, what angle the lighting was coming from, what lines of sight the telescopes intersected. 3-eye Atlas has one peculiarity that makes things even stranger. We don't see the material itself. We see the light it emits, and light depends on the angle. The same layer can look different if it's rotated. That's why the first thing people who are really in the know do isn't shout, he changed the skin. They look at the rotation, because sometimes new material is simply a new side. But here's the problem again. If it were simply the other side, the change would be gradual. It would gradually reveal a new region as it rotated, and the light curve would be jagged but understandable. But here, the effect feels like a switch. Yesterday one thing, today another. This doesn't fit well with just turned. It sounds more like something on the surface actually changed. And that's where two words come into play. Words that don't sound scary but add a bit of edge to the story. Layer and coherence. We're interested in how well this outer layer holds together. A comet isn't a monolith. It's like a snowball mixed with dirt and pebbles. A crust often forms on the outside because the volatile material escapes, while the heavier material remains, compacting and sintering. The crust can hold the surface like a shell, and if the shell cracks, you get a sharp release. But the release is usually noisy. Dust, a cloud, a dancing tail, everything goes haywire. And here, the change in optics looks as if the layer has disappeared, but without the messy explosion, and this is the most unpleasant of all natural options, because then, we're talking not about an explosion, but about removal. Imagine a film on your phone. It's matte. You peel it off and the screen becomes glossy, bright, and dramatically different. It's a change of lens without the explosion. The outer matte layer is simply gone. Only here, instead of a phone, there's an interstellar object, and instead of fingers, what? It's this what that makes the story come alive. Because if the layer is gone, it means there was effort. Maybe it's mechanical. The rotation accelerated, the crust couldn't withstand it, and centrifugal force threw it off. It happens. Comets sometimes break apart like this. But then we should see accompanying effects. Debris, dust, changes in the coma's shape, changes in the angular momentum and the light curve, and if none of this is present, then the ejection wasn't abrupt. Then what remains is this. The layer came off in chunks, thinly, carefully, as if it had been ground away. Not in one fell swoop, but along the perimeter, and overnight it simply crossed the threshold of visibility. It became noticeable. And here a strange logic emerges, one that's hard to forget. The visibility threshold very often coincides with the point where the surrounding environment changes. Not the sun, not the planet, but plasma, dust, streams. Space isn't empty. It's not air, but it's not a vacuum in the everyday sense. There's dust, there are charged particles, there are magnetic fields, subtle but real. And when an object passes through a region with a different environmental density, it can begin to blow off or scrape the outer layer differently, like an airplane caught in the rain, and the image on its windshield suddenly changes. Now imagine 3i Atlas crossing such a node, and that's where its skin changes. Then the question turns from mysticism into a map. Not what it was, but where it was. Because if we find exactly where it switched, we can predict where it will switch again. And this is where it gets truly creepy. Because if it's doing this in specific areas, it's not just reacting to heat, it's reacting to the structure of the environment. But the structure of the environment isn't chaos. It's connected to magnetic lines, to currents, to the sun's breathing, to the movement of interplanetary plasma, to the invisible roads that run through the system. So we suddenly find ourselves in a story where 3i Atlas seems to be reading a map that we don't usually show to the viewer. We're used to showing planets and orbits. But there's another map, a more subtle one, a map of fields and flows. And if he knows how to use it, he might appear normal on the orbital diagram and completely abnormal in the real world. Do you feel the difference? The orbit is a line on paper, and the environment is what that line crashes into. And the change in the outer layer overnight tells us it's not just flying along a line, it's interacting. Now the most important thing, why is this a shock at all? Why isn't it just comets do this? Because the speed and purity of the effect are suspicious. A comet can flare up, a comet can fade, a comet can collapse a chunk, but a comet almost never does it in a way that looks like a neat toggle switch in the data. And with 3i Atlas, it feels exactly like that. Yesterday the surface was one thing, today it's another, and it's as if it's part of a system, not a coincidence. And then what always happens when a system emerges, happens. People start looking for a cycle, not because they like theories, but because a cycle is the only thing that turns fear into a prediction. If it happens again after a certain amount of time, then there's a pattern. If there's a pattern, then there's a reason. And if there's a reason, then you can catch it next time. And this is where the subtle game comes into play. The object flies, and we build an observation schedule like an ambush. We plan the telescope windows so as not just to look, but to catch the moment of switching. Because if you catch the input switching, you get an answer as to what exactly changes first. Dust, ice, temperature, gas. It's like catching the first second of a fire, rather than looking at the ashes. And the worst part is, if he does it again overnight, and again in a knot, and again so cleanly, it will mean that he has a mechanism for quickly rebuilding the outer layer. Then the surface becomes not an external consequence, but a tool. Just like a living creature's skin changes to suit its environment. Not rationally, but functionally. And if 3i Atlas can adapt like this, it can change more than just its brightness. It can change how it gives off heat, how it charges, and how it interacts with dust and plasma. This means it can also change what concerns us most, its visibility. It can become a different object in the eyes of our models without changing its mass or its core. This makes him the perfect deceiver, not because he wants to deceive, but because he is physically capable of appearing different while remaining himself. And now I'll tell you something that sounds like a movie, but is essentially simple. If the surface changes, it means something is cooking inside. Because the surface is a lid, it's what separates the inside from the outside. And if the lid changes overnight, it means the pressure, heat, or structure inside is already at breaking point. And then the next question becomes inevitable. If this is a skin change, then what will happen when he sheds not the film, but the shell? Because the film changes appearance, the shell changes behavior. The shell reveals what was locked away. And if there's a layer inside that hasn't seen the light of day for millions of years, its release won't be silent. Now keep this in mind, we're not talking about the apocalypse, we're talking about a scene captured by telescopes that shatters the calm picture. Because if 3i Atlas has internal layers that come out on schedule, then everything we've seen so far has been an introduction. And yes, we can catch the next moment, the only question is whether we'll have time to put our eyes where it's going. The trickiest part of this story is that skin change may seem like a minor detail, like cosmetics, like a debate over sheen and shade. But in reality, it's one of the most reliable markers that an object has entered a phase where it's no longer simply flying, but rebuilding itself. Because the surface is the first line of contact. Everything that happens inside first manifests itself on the outside in this way. The way it reflects light changes, how it retains heat, how it produces dust, how it breathes gas. This isn't poetry, it's physics, just translated into the language of the camera. And that's why observers are starting to look not at a pretty picture, but at what they call a behavioral package. Not just one parameter, but a whole bunch. The brightness, the color, the shape of the coma, the stability of the tail, and even how smoothly all of this changes over time. If this is a real change in the outer layer, it's almost bound to trigger another change, a change in how the object loses mass. Sometimes this change is very slight. Sometimes it's only noticeable as the coma becoming denser, or conversely, clearer. But if an object changes its outer layer overnight, it means that something either settled, or something was torn off, or something came out. And all of this leaves a trace, even if it doesn't look like an explosion. Here's what I want you to imagine. You have an old coating that was acting as insulation. It kept the inner layers closed. It made the object dumb and predictable. And suddenly, the insulation disappears. Then the inner region begins to directly contact the external environment. And even if there's no significant ejecta, the evaporation regime changes. The way heat is lost or accumulated changes. What's called the comet's breathing changes. And then a terribly simple question arises. Why now? Why not a week ago? Why not in a week? Why tonight and overnight? Such coincidences are rarely accidental. When something happens abruptly in space, there's often a geometric reason, an angle to the sun, an angle to the earth, a rotation of an axis, a plane intersection, entering a new sector where the external environment is noticeably different. And if you want to make a retention story out of this, you do one thing. You stop saying, he changed, and start saying, he crossed a boundary. Because boundaries are something people understand immediately. Not a boundary on a map, but a boundary of conditions. It's as if he's entered a different climate. As if one step and the pressure changes. We can't see this boundary with our eyes, but instruments detect it by how the object behaves. And now we come to the main nerve. If 3i Atlas has boundaries at which it switches skin, then these boundaries exist not only for it. They exist for everything flying through the system. So this is no longer a story about a single object, it's a story about the solar system's hidden structure, one we typically ignore in popular narratives. We draw planets, but we don't draw roads from fields and streams. And then 3i Atlas becomes more than just a guest. It becomes a marker. It shows us where these roads lie because it reacts to them too sharply. You ask, okay, so what next? Then the hunt for a repeat begins. Because 1 episode is a surprise, 2 episodes are a signal, 3 episodes are a pattern that can't be ignored. If the surface change happens again overnight, and again near a specific node, then a very dangerous thought arises. This isn't material degradation, it's a cycle. This is routine operation. And regimen operation means that within the object there are layers that are activated one after another. Not because someone presses a button, but because that's how its structure is designed, and the external environment only triggers the switching. You rarely see the layered work so clearly in a regular comet. Yes, comets are layered, but usually it's all masked by dirt and chaos. Here, it feels as if the chaos has suddenly become discipline. Now imagine the second step. The surface has changed. This means how it behaves under solar pressure will also change. It's a very subtle force, but it works on dust particles and gas like wind on ash. If the outer layer has become smoother or more glassy, dust may adhere differently. If it has become looser, dust will fall off more easily. This means the tail will change shape not simply due to activity, but due to the material. And here are the frames that the viewer remembers. The tail, which yesterday was wide and cloudy, and today has become narrow as a blade. The coma, which yesterday was a cloud, and today has become like a shell. Normally this is explained by a turning of the jets, or a change in activity, but if it coincides with a change in the surface's optics, you get a story where everything fits into a single gesture. And this gesture looks like this. The object sheds a layer, changes its behavior, and does it quickly. And speed in space almost always means there was pent-up energy waiting to be released. And here I must distinguish between fact and conjecture. Fact, we see a change in how the surface reflects light. Fact, this happened abruptly between observation windows. Fact, it looks like a new outer layer. The conjecture begins where we discuss the cause. Was it a film of dust that fell off? Was it a new layer of ice that settled? Was it a shell that cracked and closed again? But even if we're wrong about the cause, we won't be mistaken about the key meaning. The object is capable of changing its external mode so quickly that it's noticeable not on specialist charts, but on the object's face. And you know what's most disturbing? This behavior has a sequel, which almost always follows in cometary physics. If the outer layer changes abruptly, the next step is often even more abrupt. Because the first discharge is usually minor. Is just removing the top dust, then comes the time when the layer that previously held the volatile material's internal pockets is exposed, and when such pockets open, it's no longer quiet. The gas escapes in such a way that it begins to push the object itself, and then you see something that scares engineers more than a beautiful comet. You see a small but consistent deviation in motion that repeats. You see that the object isn't just raising dust, it's being jolted, and these jolts begin to look like a rhythm. And if the rhythm appears after the skin shedding, it means one thing. We're not just witnessing a pretty anomaly, we're witnessing a transition to a phase where 3i Atlas will begin to do things that can no longer be attributed to a random moment in the frame. Now I want to bring you to the stickiest point of this story. If the outer layer can be replaced overnight, then an object can change more than just its appearance. It can change what we consider its nature. Today we think it's dusty, tomorrow it looks icy. The day after, it looks like dark rock, but in reality it's the same object revealing different layers, like pages. And when you understand this, you stop asking, what is he? You start asking, how many pages does he have left? Because each page could be worse than the last. Not worse in the sense of a threat to Earth, but worse in the sense of how much it disrupts the conventional picture. Because the deeper the layer, the less it has been processed by the external environment, the more primordial it is. And if the primary layer is exposed abruptly, it can behave like a material that has never seen such conditions. It can evaporate differently, it can break down differently, it can produce a spectrum that throws off the models. And that's why many will be monitoring to catch the next turning point. Because the first turning point has already happened, and if it wasn't a one-off, the next one will be even closer. This means the most interesting things are yet to come, not because I want it that way, but because the physics of layer and stress rarely stops at one episode. It continues until the system sheds what it has accumulated. And when that moment comes, you won't see it as a thin line like optical properties. You'll see it as an event that can't be explained in a single word. And then the story will stop being about shine. It will be about what 3i Atlas can do to itself before our eyes, quickly, and in such a way that we always think, wait, this shouldn't be happening. And this is where many people often make a mistake. They think that if an object changes clothes, it means it's become different. In fact, it's often the opposite. It's become more of itself. It's just that before, we only saw the top layer of garbage, but now we see what was previously hidden. The dusty crust is a mask that smooths everything out. It hides pockets of ice, conceals cracks, and obscures real contrasts. When it disappears, the surface ceases to be average and becomes sharp as if it has edges. And then it seems artificial to you because we're used to seeing sharpness in manufactured objects. But space can create sharpness too, just rarely, and not when it's convenient for us to see it. The strangest thing is that after such nights, observers get the feeling that the object has begun to adjust its rhythm. Not its speed, but the rhythm of events, as if it realized that if it does everything quickly, people won't have time to notice it. And here, one simple thing shouldn't be underestimated. Most observations involve windows, night, weather, cues. Even when everyone is watching, they do so in fits and starts. And fits and starts are the perfect environment for abrupt changes. If you want to capture the moment a layer changes, you need continuous control. And that's almost never available. That's why such events look like a trick. Yesterday, one object, today another, and everything in between seems cut out. And then something happens that doesn't usually make the news, but changes everything in the scientific world. Archives are compared, not of current data, but of old ones, and suddenly it turns out that a similar switch has already occurred. It's not loud, it's not obvious, it's just that one of the datasets also had a night earlier, after which the reflectance profile changed. Back then, it was attributed to noise, now it's becoming a second seam on the same fabric. When the second stitch appears, the fear turns cold, because once, anything can explain it. Twice, that's a pattern, and a pattern forces you to look for the cause not in randomness, but in mechanism. And here I want you to imagine the mechanism in the simplest possible way. The object has layers, like an onion. On the outside is debris. Below that is denser material. Below that is ice and rock in a different ratio. And somewhere inside are pockets. A pocket isn't a cave. It's a zone where volatiles are more densely packed. It can remain sealed for millions of years, and when the outer layer weakens, the pocket gets a chance to breathe, the vacuum, and open up. Usually it looks messy, a surge, a stream, chaos. But if the pocket opens as a narrow crack, it can produce a very focused flow, not like a cloud, but like a cutter. And then, the surface around the crack changes rapidly. It might become covered in frost, or conversely it might become darker, because the gas carries away fine dust, leaving behind coarse dust. In both cases, the optics change dramatically because you're altering the microstructure in one sector. Now listen carefully. If the change in optics is related to the directional flow, then there's another trace that can be detected. Not in the image, but in the movement, because the directional flow produces a micro impact. It's not an engine. It's like breathing, pushing a boat. It's weak, but if it's focused and repeated, it adds up to an effect. And engineers thrive on such weak effects. They can see millimeters where the human eye sees zero, because zero doesn't exist for navigation. It either matches or it doesn't. And if, after a nightly skin change, the trajectory deviates slightly from the calculation, that's a hitch. The combination of the surface has changed and the dynamics have shifted slightly marks the moment when the story ceases to be aesthetic and becomes an event. Because now, it's not about how he looks, but what he does. And that's what JPL hates most. Not the loud anomalies, but the quiet ones. Because the quiet ones ruin planning. You can't explain a quiet shift in a single word and close the ticket. The most annoying thing about silent shifts is that they tend to repeat themselves. If the subject opens a pocket, it might close again, then open again, and each time you get the same scene. Night, shift change, a small jolt. That's why everyone starts looking for a period. Essentially, they're trying to figure out, is it rotation? Is the object experiencing a season? Is it aligned with its direction toward the sun? Or is it tied to the environment, to invisible bands in the interplanetary plasma? And here's something important that isn't usually explained to the viewer becomes important. An object doesn't just have a trajectory. It has an orientation. It has an axis of rotation. And if the axis is positioned such that one side regularly facing the flow, you'll have rhythm. So, one night might not be magic, but rather a moment when a previously hidden section of the world turned toward us. But again, there's a problem. The shift seems too abrupt even for a turn. And then there's the third thing. He didn't turn around. He changed. He didn't show the other side, he switched to a different mode. And a mode almost always has a trigger that's independent of our perspective. For example, charge, surfaces in space charge, dust charges. When the charge changes, small particles can detach or adhere. This can change the optical skin in literally hours. And this sounds like quiet physics, but the effect can be spectacular. Yesterday, the surface was matte because it was coated with fine dust. Today, the dust has come loose because the charging conditions have changed, and you see a smoother surface. You might ask, why is this specifically related to 3i Atlas? Because the interstellar visitor could have a different composition. It could have different dust, different ice, different electrical conductivity. What's mild for the local comet is harsh for it. And here comes the next crucial moment in history. If the outer skin changes so rapidly, then all the familiar models of what it is become fluid. We lose track of which part of its surface is currently active. And if we don't understand which part is active, we don't understand what the next surge might be, because surges are tied to specific zones. It's not a general body temperature. It's spots, cracks, pockets, seams. And then you understand why it's so gripping. Not because it's scary, but because it takes away our control. We're used to it. There are parameters, there are calculations, there is a forecast. But here, the forecast starts to look like a bet. The scariest part isn't even that it changes. The scariest part is that it can change appearance so that different instruments will produce different versions of an object at the same time. The optics will say it's gotten brighter. The thermal channel will say it now holds heat differently. The radio will say the gas is coming from a single point, and altogether it will look like a layer change, not chaos. If you catch this in 1 week, there's no going back to the phrase ordinary comet, because ordinary ones don't have the ability to so carefully reconfigure the parameters without a visible major event. NASA comes into play with its most boring yet most powerful force. Reports, repeated observations, multi-channel confirmation, careful wording. They'll never write change skin. They'll write reflective properties changed. But the meaning will be the same. The object changed on the surface, and it happened too quickly to be dismissed lightly. And you know what makes this truly dangerous for our peace of mind? At times like these, many people start asking not what will happen to Earth, but what will happen to observations. Because if an object can shift between modes, it can become too bright, too dim, too clean, too dusty. It can break the calibration and force us to recreate its image every time. And when you reassemble the image every time, you lose continuity. You stop seeing the plot. You're left with frames, and frames are easily deceiving, even if no one is deceiving anyone. And that's why the next goal is simple and terrifying. To catch one more night, to catch one more switch, and not just to see before and after, but to catch the moment when the layer begins to peel away. Because that's where the answer will be. That's where the first second of the process will be. Does dust fly? Does frost appear? Does the coma twitch? Does a narrow stream appear? And most importantly, does a small jolt appear in the movement? If we grasp this, we'll stop arguing over beautiful words and see the bare mechanics. And bare mechanics sometimes sound more frightening than any conspiracy theory because it leaves no room for it will go away on its own. And that's why I say the story has only just begun. One night isn't the end. It's a warning. This is the first time 3i Atlas has done something so quickly that we even noticed it through our windows. And just when you think it's just waiting for the next night, something appears that actually makes people's fingers go cold. Because light can deceive, and the spectrum almost never deceives. A spectrum isn't just about looking pretty. It's a chemical fingerprint. It's the answer to the question, what exactly reflects light, what absorbs it, and what transmits it back. And if your skin has changed, the spectrum should confirm it. And here comes the subtlety. On the first night, everyone sees changes in brightness and tilt. On the second night, someone finally manages to take a proper spectroscopy, and what emerges is more than just slightly different. There's a sense that the surface has become more uniform, not in terms of color, but in the sense that the familiar mud of mixed fractions has disappeared. It's as if the upper chaos has been removed, leaving behind a pure dominant element. That's why it sounds like a material change, because a typical comet spectrum rarely suddenly becomes cleaner. It usually gets dirtier because activity increases and everything gets mixed up. But here it's the opposite. It's as if someone made the surface more collected. Less random scattering, less noisy dust, more of a smooth response. And it's the same motif again. Not chaos, but order. The natural reaction is to blame it on geometry, on the phase angle, on the way the light falls. Yes, geometry can change appearance, but geometry can't change a chemical hint so that it looks like a different mixture. And when this is understood, the most unpleasant word in such stories begins. Not sensation, not anomaly, but overestimation. Because if skin can change like this, our estimates of size and reflectivity can fluctuate too. And if the reflectivity fluctuates, then the distance and size on the graphs begin to look different. You think the object is such and such, but it's simply lighter or darker due to the surface, and you catch yourself thinking that part of your confidence was an illusion. And here's where something happens that viewers love because it feels like a leak, even when no one calls it a leak. Several groups are independently saying the same thing. We're seeing a transition. Not fluctuations, not noise. A transition. As if the object has crossed an internal boundary and now we're looking at a different layer. And this isn't just a terminology dispute. It's a convergence of different people's conclusions. At this point, everyone is trying to grasp the simple picture. What could be hiding beneath the surface dust to produce such a collected answer? There's an option that sounds mundane, but its consequences are dire. It could be a compacted crust of small particles that center together and become almost smooth. Such a crust can behave like a single material. It can reflect light differently, making the object appear different. But the problem is that crust doesn't form overnight. It takes a long time to form. That means it was already there. We just didn't see it because there was a loose layer on top, and the loose layer disappeared so quickly that we noticed a jump. That is, if there was a crust, it means the object has long been living with internal tension. Under the crust is pressure, under the crust is volatile matter, under the crust are pockets, and the crust is a pot lid, not a decoration. And if the lid has become the main visible surface, it means the dust mask has been removed and any cracks will be more pronounced, because crust cracks differently than loose dust. Loose dust falls, the crust breaks, and when the crust breaks, you get not a cloud, but a gap. And a gap in a comet is almost always a stream, narrow, directed, sharp. And here comes the moment when one of the main witnesses of such things comes into play. The Hubble Space Telescope can do what Earth can't always do, observe steadily without an atmosphere and detect subtle changes in the coma's shape. And if in the same week after the skin sheds, the coma's shape begins to gather into a strangely localized pattern, this becomes a second wedge in the same door, because the coma is what the subject is exhaling right now. If the coma becomes more structured, if it stops being just fluff and begins to look like a system of jets, then something directional has truly opened up inside. And directional almost always means mechanics. Here the viewer usually wants to shout, "He's maneuvering." But that's a superfluous and harmful word. We don't need maneuvering, we need the fact. The directed release of matter produces directed acceleration. And if there is acceleration, it can be very small. But small acceleration, repeated, produces an effect that looks like character, like a signature, like an object's habit. And now comes the stickiest part. If an object can change its surface quickly, it can also change the direction of its jets quickly because the jets are tied to active zones. An active zone opens, an active zone closes, and the behavior changes. This means we're not dealing with a single constant jet, like a comet that's used to spewing dust from one side. We're dealing with switchable zones. And that's why the story holds so tightly, because the switchable zones are almost like an interface, not in the sense of an artificial layer, but in the sense of a physics-driven layer. And then something even more unpleasant happens. Someone tries to find the associated debris from the removed layer. Where did the dust go? If it flew off, it must be in the surrounding area. If a layer has been torn off, a thin shell of particles should appear around it, spreading out. Sometimes this is visible as an expanding cloud, sometimes as a very faint streak that can only be captured in deep space photography. And if such a shell is found, it turns the skin change into a practically closed case, because you have a before, you have an after, and you have a consequence that hovers nearby, like a ghost of the old surface. That's why it sounds shocking. It's not an abstract anomaly, it's a straightforward story. There was a layer, the layer is gone, and the trace of the layer remains. Now take the next turn. If a layer has been lost once, it may not be the only layer. Cometary nuclei often have a series of crusts formed during different periods of activity. There's one on the outside, another underneath, a third underneath, each with its own composition and mechanics, and if 3i Atlas has begun to uncover them, we'll see them change more than once. And these shifts will become increasingly harsh, because the first layer is usually the most garbage-like, the most protective. Next come layers that are closer to the original material. They react more strongly and sometimes more strangely. This is where I really want to introduce a device that sees not just light, but thermal energy. The James Webb Space Telescope can look at something cold and say, how are you keeping it warm? And if the thermal inertia of the object changes after the skin changes, this will be direct confirmation that the material is different, because dust and ice retain heat differently. Stone and porous crust do the same. Do you see where this is leading? We're no longer looking at 3i Atlas as a point moving through space. We're starting to see it as a body going through phases, and each phase makes it new to our models. And at this point, the story raises a deeply troubling question, one that grips the viewer more than any scream. If he can change his skin overnight, then he has a way to dramatically alter how we think of him. Today, he's one type. Tomorrow, he's another type. And it's not because he's become different. It's because he's revealing a different layer, and layers are the past, locked inside. And that's why next week is crucial. Not because disaster is approaching, but because next week we'll either see a repeat or a continuation of the process. If this was a single reset, everything will become quieter. But if this was the first click, there will be a series. And a series is something that can no longer be called random. And when the series begins, we'll see the most terrifying thing for the calm picture. We'll see that 3i Atlas is capable of changing external physics so quickly that each new batch of data will look like a new object. And then the question becomes quite simple. Not what is it, but which layer will emerge next, and what will it do when it first touches our environment? And this is where things get really nerve-wracking, because next layer isn't just a poetic phrase. It's literally a question of what material will surface after the next drop, and how it will behave in a vacuum when it's first discovered. The first layer usually acts as insulation, like a dirty jacket the comet wears for years. It protects, dulls, and smooths everything out. When the jacket comes off, the body becomes visible, and the body is often not ready to be exposed. So what follows is almost always not silence, but a series of small events. Not cinematic explosions, but short dry transitions that appear as steps in the data. Each step represents a new surface regime. And you know what makes steps truly unsettling? They're almost always accompanied by a change in how the object polarizes light. It's a parameter the viewer can't see, but it reveals the structure. Dust scatters light, chaotically, and the polarization is uniform. A smooth layer gives a different response. Ice, porous deposits, freshly ejected particles, all leave a signature, and the signature changes dramatically if the layer is removed abruptly. So we don't get a single, it's become brighter line. We get a package of independent confirmations. And when there are multiple confirmations, the problem is no longer what we see. The problem is what triggers it. Because the surface is a valve. If the valve becomes thinner or cracks, the internal fluid will begin to leak more frequently. And every leak is a chance for another crack, because the gas doesn't just escape, it eats its way through. And then a very simple mechanic emerges, one that shatters the composure. The more often the gas escapes, the more the surface loosens. The more it loosens, the easier it is for the gas to escape. It's a feedback loop, and it likes to accelerate. That's why after the first regluing of the outer layer, people wait for the second. Not because they want a sensation, but because feedback rarely stops at one step once it's started. Now imagine the second step happening not on the same side, but on the other. Then the object begins to look as if it's changing faces in different directions, and each face has its own life. One side darkens, the other brightens. One side emits energy, the other remains silent. To the viewer, it appears as a riddle. To the dynamic, it appears as a shift in the center of activity, and that's serious. Because when the center of activity shifts, the rotational momentum changes, and rotation can accelerate. And rotational acceleration is a classic cause of splitting in cometary nuclei, even in quite ordinary ones. Only here the word ordinary no longer clings, because we see not chaotic mud, but structural transitions, as if the object retains its shape while simultaneously changing its shell, layer by layer. And here comes a moment that grips the viewer better than any promise of the end of the world. If it speeds up the rotation even a little, we'll see it in the light curve as a pure period. The rhythm will become more stable. A stable rhythm in an object that's supposedly in chaos always looks wrong, because chaos doesn't like stability. And here, stability can appear precisely after resetting the layer, as if the brakes were released,